Because one time you didn't
Yep.
until I said so.
Yep.
You did that a couple times.
I have managed to lecture a little bit without turning the screen on. Boy, did I feel dumb. Kind of try to reinforce myself to do that by, if I miss part of the lecture, I go and re-record it, and that's a pain. Okay, so what am I going to do? Well, the first thing I'm going to do is I'm going to launch idle. Those of y'all who are using Pycharm, I wish you'd make me a tutorial that I could give to some students in my 1113 class because they're having problems with it. Okay, yeah, I really ought to do it.
For Pycharm?
Yeah, you can use Pycharm. I'm sorry if I haven't demonstrated Pycharm yet. It takes a while to load, so I'm going to just get it loading in the background. It's something you can install. Pycharm doesn't come with Python, but it's an easy install. And it's worth learning. It's worth learning how to use it because it's frankly a way better editor than idle. On the other hand, idle launches within seconds. It's kind of smooth, clean, and small, whereas Pycharm's a much bigger project, a much bigger program to load. But it's far closer to the development environments that you might use in Java and C++. Specifically, if you're a Microsoft Windows developer, you're going to use one called Visual Studio. It's kind of top grade as far as development environments go, but there are other ones as well. So we're on Lecture H. Okay, so what am I going to do? I'm just going to make some functions that do some silly kind of math. We already know how to multiply numbers. You just use the asterisk. But let's pretend that our language did not come with a multiply capability. And so we were going to write a function that did multiplication for us. So def mult, and it needs to be able to multiply two numbers like x or y. So def mult is going to take x and y. So parentheses x comma y end parentheses. Now it could be really clever, and you know what multiplication is. It's just a form of adding where you add something over and over and over, right? If you're multiplying 8 times 5, you add 8 to itself 5 times. And I'm not going to do that. I'm going to go ahead and cheat, and even though I said that we were doing something, you know, in a world where we didn't have arithmetic operators, our modules are allowed to use it for the purposes of this example. So we're going to say the result is equal to x times y. Then we're going to say return r, because if you define a module and it doesn't return anything, then the code that called the function won't get anything back. And sometimes that's okay. Right? Like if you tell somebody to go do something and you don't care for it to report back, you know. Go to Walmart, buy some stuff, and don't report back. Don't waste my time, right? But here we are. We're calculating a value. We definitely want to be able to return the value. And let's make sure that it works, right? So what am I going to do? I'm going to say A, notice I back tabbed all the way against the border, is equal to mult parentheses 10 comma 20, and that's going to be 200, right? So if I print A, print parentheses A, it's pretty predictably going to show 200, unless I've made a syntax error and I'm not spotting one before I run it. So here I go, and it ran 200. All right, so big deal. We knew how to do that. We've done that once or twice already. But here's the thing. Once I've run that module, it's already imported. Idle imported it into the shell, ran the program. I could use it myself, right? I could say, you know, B equals mult parentheses 2 comma 3 end parentheses, and I'm doing this in the shell now, not in a program. And then when I print out the value of B, 6, right? So the modules are loaded. I use the plural, singular, right? and I shouldn't keep using the word modules. Sorry, I walked in from fundamentals where for some reason the textbook calls everything a module rather than a function. This is a function. Let's go ahead and put that there, and maybe I'll remember to call it the right thing. That is a function. Just like a math function, right? You know, you could write a function that, you know what a math function is, has parentheses and returns a value. Okay, so what's cool about that is I could open up another file and import this file and get all the capabilities that this file has, which is right now one function, right? But we could stick in a whole bunch of math functions. We could make one that did subtraction and another one that did division and so on. We could even try to come up with a cool one that accepted 3 numbers and multiplied all 3 of them together. That might be fun. So I'm gonna, no I'm not gonna do that. Let's get to the real meat of the matters. I'm gonna make a new file called Lecture H2. Or whatever you want to call it, just don't give it the same name as this module, as this Python script. It needs a different one because I don't want to erase my old one, right? So I'm going to save as and call this one Lecture H2. It needs to be in the same directory. Lecture H2. And again, we're going ahead of the book, but that's okay. You see it in front of you in class, then you go back to it in the book. It makes perfect sense. All right, so what am I going to do? The first line is going to import this Python file, Lecture H. I'd strongly recommend getting the case exactly correct. So if you did what I did, which is capitalize the L and the H, do the same thing. So up here at the top, I'm going to do import lecture h.py, capitalized exactly.
Why am I getting a syntax error?
I'll come over and check. I don't want to get too far ahead of people. But now I can do the same thing, right? I can do C equals mult parentheses, and I'm going to multiply 10 by itself. C equals mult parentheses, 10 comma 10 in parentheses, and I'm going to print the result out. It should print 100 out if I've done it all right. Let me make sure I have. You better save both of these. So if this one has an asterisk over here and you're using idle, that means the file hasn't been saved. Idle does not go and magically save every document that you run. It will save the one that you're currently editing, right? So if I run it over here, it'll ask me if I want to save it. Yeah, I sure do. But I better save this one as well. No. Save, I said. File save.
Because what if your computer had a massive computer failure?
Well, hopefully not. All right, let's go. All right, and I called it lecture h.py. Kind of made a mistake there. Let's just see if it's lecture h. Hope I don't botch this too much. Well, not defined. Says who? My problem is that since I imported it with this syntax, it wants me to prefix this function call with the name of the module it was imported from. So I would have to type in lecture h.mult. I think instead I'm going to import the function in a way that I don't have to prefix it with that. So instead I'm going to do this. From lecture h, capitalized correctly, import my mult function. Kind of like surgical strike. It just brings in the one function. I could have 8 billion functions defined in here, but it brings in the one function that I want. And you'll see that syntax perhaps in the book. If you just want to bring in one thing from the math library, then you could use from math import something. All right, cool. It totally worked, but it did a little too much. What was this program supposed to do? If you didn't have this over here, if you were just looking at this, you'd be sure would be perplexed as to why it printed 200. Nothing over here printed out 200, right? So what did it do? It took, as it was importing Lecture H, it also executed the code within it. So anything that was unindented got run. I could prove that by coming back and adding a print statement over here to my original file. Oh no, right? Like that. So when I do that, well, I need to save this side. I go back to the other one, and when I run it, okay, right? We've got hard evidence right there that it's running Lecture H as soon as it imports it. You might not want it to do that. Well, what could you do? Well, one thing, you could comment all this stuff out, right? Another is that we can enclose our main code in a special kind of function. It looks like this, in a special kind of block. We could call this if, and this syntax is very, very specific, and if we get it wrong, it's not going to do what we want. If underscore underscore, 2 underscores, double underscores, name, end underscore, or just 2 more underscores, see, 2 on each side for a total of 40, equals equals, double quotes, and inside those, underscore underscore, main, 2 more underscores, colon. And then take those 3 lines of code, cut them, paste them, and tab them over. Right? So our original file is going to look like this as soon as I cut those 2 lines. And if you don't get this to work, that's okay. I want you to see it this time at least. Right, so all 3 of these lines need to be tabbed over. Let's prove that this works on both sides now. So if I do run module, it printed out 200, oh no, just like it was supposed to do. If I go to the other side,
will it print out, or is it going to give us a syntax error?
yeah, it's not going to be a syntax error. But it's certainly not going to print out, oh no, and that's what we want to see gone, because we don't want it to run the whole program. It'd be like if I imported Turtle, and as soon as I imported Turtle, it went ahead and drew a whole bunch of stuff, rather than wait until I told it to draw something. Okay, and this time, see, it actually only printed out 100. So what did this do? It marked off this code as saying only do this if I actually run this specific module, not when I import it. That's why if I come over here and run it, it doesn't do that stuff, right? But if if I run it from this side, if I run this module, if I'm running it from Lecture H, it goes ahead and executes it. But if I come over here and run it from the one that imports it, it doesn't do that stuff.
It doesn't do that. Oh no.
Yeah, so if we were really cool and awesome, we'd be doing this if underscore underscore name equals main every time we wrote a program. Now I might not do that, right? Probably not in this class because that's a lot of extra typing. Although we could create what in C++ I called a boilerplate file, and we just copy and paste it in every new file we go. I should be doing that for every program I write. I should mark off my code like this so that the main code is no longer unindented. Some people even call it a main function after other languages like Java and C++. Except it's not a function, is it? What if we wanted to make it a main function? Couple more changes and then we'll get off this topic. I'll walk around, make sure it's working for everybody. I heard we had a syntax error. So here's what I'm going to do. You see those 3 lines? I'm going to cut and paste them one more time. And I'm going to do DEF space main, parentheses in, parentheses colon. I'm going to paste, make sure they're all indented exactly the same. And then down here, this code marked off inside the if block only has a call to main. So now our original file, and I'm not going to mess with this lecture 2-bit anymore. I'm just going to close it. We don't need to see this anymore. But I'm going to keep the original lecture file open so I can keep making changes to it. The way it looks now is we have 2 module definitions, and then we have an if block that calls this one. This is actually a far better way of doing it. If you're Googling Python code on the internet, you'll probably see references to it. And even though I'm not going to explain what underscore underscore name means and underscore underscore main, just accept it as a matter of faith for now that that works. It's not the only time you'll see things that you just have to so-called accept on faith. If I went in to a Java or a C++ program, you would see a main method with a very specific syntax you had to follow with utterly no explanation at the beginning of class, at the beginning of the semester, why that syntax was what it was. Okay, let's make sure that I haven't broken it one more time. I'm going to run the original file, make sure that it's working. It should print 200, oh no.
Oh no, we failed.
Yeah, but we actually succeeded. We got it to do exactly what we wanted.
In that line, that if name, what does that do exactly again?
It checks to see what context this code is being executed in. If this library is imported, it won't run that.
Oh, okay, if it's imported.
Yeah, if I go to that other file that I had created when I execute it, when it imports it, it doesn't run whatever's after that if statement. But when I run it from this file, it does.
Okay.
So it cordons off the code so that your main code, the stuff that was previously unindented, doesn't get executed when you import it from another file. And at the very least, it impresses your friends when they come and look at your code.
I noticed that when I was doing some of the homework is this.
Oh my.
So the last thing we saw was the use of if statements. And the book wanted us to zero in on the idea that you can do just if else, like that, do one thing or the other. Or you can use if, elif, else. And if you've used other programming languages but not Python, then elif looks weird because you're used to typing else if. This particular language is called elif. So these are what are known as the truth tables. I think I drew this, except where I did zeros and ones on it and showed that they were akin to multiplication and addition. What this is showing is that if you have 2 variables, the operands, the things on each side of the and, the only time it's true for and is when they're both true. And that makes sense, according to how we use it in English. If you're hungry and your friend is hungry, you're going to eat. Maybe you're not going to eat if your friend's not hungry for some reason. If you are hungry and you have food, you're going to eat, right? You have to have both. You have to have hunger and food. Well, maybe not. Maybe you snack even when you're not hungry, but whatever. Or is true when either operand, when either side of it is true, right? Like if you're hungry or you have food. Well, that doesn't make any sense, right? But if you are sick or tired, you get to stay home. Generous boss if he lets you stay home when you're tired. And lastly, there's one more logical operator, not. That works like this. I'm going to come back to main and just add a little bit more code. We're saying right now that A is going to equal 200 if we wrote our functions right. I'm getting tired of seeing oh no, so I might delete that. but I am going to write an if statement. If A equals 200, colon, print, parentheses, quote, yes, end quote, in parentheses. But how about not? If A not less than 0, colon, print, parentheses, maybe, end quote, or end quote in parentheses, right? So what is this going to do? I put the not in the wrong place, so it's not going to do a darn thing. I'm going to cut that and put the not in front of A after the if statement, and there we go, right? So what does this do? Well, the first thing it does is it evaluates all that. It's kind of what's known as right to left associativity. It's got to do this part first. So if A really is equal to 200, is it less than 0? No, it's not less than 0 if it's equal to 200, so it's not going to print maybe. I could prove that by deleting that not keyword and running. I'm not going to see maybe execute. Right? But if I come back and put that not keyword back and in its proper place, it's reversing the truthiness of it. Colbert used to always use the word truthiness. Right? If this was true, it's now false. If it was false, it's now true. So, A less than 0? No, that's not true. That's false. But, oh, right. Just the way we think about it, right? If A is not below 0, if the temperature is not less than 32, it's not ice, right? If temperature is not less than 32, it's not freezing, right? And so the truth table for that looks like this, right? Whatever the expression is here, whatever that value is here, if it was true, it becomes false. If it was false, it becomes true. This is part of Boolean math. And if I was able to edit these things, and I'm not going to take the time to edit again, I really think that I did it in the last lecture. If I go back and look at lecture G, you'll probably see it. Well, you know, I didn't. Maybe I put it in a notepad that I didn't save. If we look at this and you pretend that all the trues are ones and all the falses are 0, then this would be 1 times 1 is equal to 1. That's true. 1 times 0 is equal to 0. Also true. Anything times 0 is 0. Hope that's actually 100% true. 0 times 1 is 0. And 0 times 0, of course, is 0. So, in some classes and some applications, and is thought of as a Boolean multiplication. And when you're expressing a statement as a formula, then you'll use some symbol that means asterisk to indicate and. There's also another symbol that's used for and I forget whether it's an up arrow or a down arrow.
It's up arrow.
It's up arrow, okay. Or is akin to logical addition. Why do I say that? 0 plus 0 is 0. True enough, right? 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is, okay, you want to say 2. But this Boolean math is a world where there's only 2 possible values, right? 1 and not 1, right? True and not true. So there's only one possible value here, or 1 or 0. So true plus true is equal to true. 1 plus 1 is equal to 1. So, or is akin to Boolean addition.
I guess you have to take discrete math.
I bet they go over this in discrete math. I may tack that on as a comment. I know it's going to mess somebody that all of our main code is now indented. So anyways, if we do this, I'm just going to say and is logical multiplication. And I know I'm slightly botching it. If you're a math major, you know a better way of phrasing it. And or is logical addition. If that helps you memorize the truth table, great. If it doesn't, jettison it until you take discrete math or a logic course.
Yeah, I'm taking discrete structure.
Although rules of you know how you can do this? A, B plus C winds up being A, B plus AC. The same thing is true of logical expressions. So sometimes you can simplify your logical expressions by being able to do something like that. If I had if A and B, or A and C, and these were clustered correctly to make sure that operator precedence was resolved, then I could rewrite that to say if A and B or C. Now, I'm not sure I would do that. I'm not sure that I'd rewrite it like that. I'd have to figure out whether I thought this was easier to read or this is easier to read. So why was I previously using A less than 0 and now I'm just using the letter with it? This is just indicative of a Boolean value. It could be an entire expression, like it could be if x equals 0 and y is equal to 0, or if x equals 0 and c is equal to 0, right? Yeah. You can store the results of a Boolean value, a Boolean expression, in a variable like this. I could say temp like temperature is equal to -10. It's pretty cold outside. And then I could put freezing equals temp less than 32. Freezing, and then I could print out whether it was freezing or not, right? Freezing, question mark, end quote, comma, and then that variable name, freezing. And it's going to print true, because it really is freezing. Or I could put it inside an if statement. If freezing, print something. If freezing, colon, print burr, end quote, in parentheses, like that. So I stored the result of this Boolean expression in a variable so that I could check it later. Sometimes people call that a flag. I was setting a flag. I set a flag that was, set to true if this expression was true, which in this case it is. -10 is less than 32. So when I run it, I should see freezing true, and then I should see the word burr. If I change it so that it's no longer freezing, like the temperature is, positive 99, well, it's no longer freezing. So I'm going to see freezing false, and then it's not going to print burr, because when that expression was evaluated, false was stored into that variable. And so if false, well, if it's false, it's not going to do that. Like that. So Boolean variables are, and you can add the word sometimes in here. I'm not going to add it because it'd run off the screen. Sometimes called flags. So as soon as I hear the keystrokes slow down, I'm going to switch over to JetBrains. I launched it at the beginning of class. It's about loaded. JetBrains, privacy, yeah, whatever.
Yeah, whatever.
That's right. Sure, go ahead and send all my data to JetBrains. I don't care. The way JetBrains works is you don't just create a new file. You create an entire project, and then you put files into it. Well, really is slow. Hopefully from now on I won't have to answer those questions, and then it'll come up more slowly. All right, so it came up with this screen, Pycharm. Create new project. Sure, why not? It's asking me for a name. nicely it's showing me the path to my project, so I could move it into my regular directory. I'm not going to bother because I'm not going to bother uploading this or anything. So I'm just going to call this sample. It's a sample project, right? Project interpreter, new virtual env environment. Sounds great to me. It has a whole bunch of stuff involved. I'm not going to modify any of that. I'm going to click create. Loading sample project. Welcome to Pycharm. Yeah, stop. It's looking like a bad program at this point, but once you get past to the point where it stops offering all these questions, like you could disable show tips on startup. Yes, it's taking a long time to load. If you have a Alienware machine, it's going to run a little bit faster. But anyways, okay. So here's my project. Doesn't have anything in it yet. So I'm going to make a new file. I'm going to right-click on it. No, I'm not going to right-click on it and choose new file. New Python file, even better.
HTML.
And so it's a Python file. I need to give it a name, test.py. Windows Defender may be, oh, that's why everything is so slow. It's Windows Defender's file. Anyways, okay, so then I could stick something in here, right? Print test. Or I could define a module in one file and then come over here and write another file that calls it, right? Then when I'm ready to run it, I think I'm going to stop right there. Yeah, there's my run method. It printed out test. And say I have multiple files going up here. If you're not going to be editing multiple files, you may not care so much about using this product. It'll help catch syntax errors. If I type this, name equals, quote, Fred, end quote, and I'm sorry that text is so small. And then I do print parentheses in, it starts to fill it in, right? So I could just double click on name and I'm pretty sure it's going to work. What if I misspell it? It underlines it. I don't have to run it in order to find out the error then. It shows me the syntax error right away. So if you're using Pycharm and you can take the additional complexity, you get some niceties like that auto fill in and the fact that it will display your syntax errors if you goof them up. Like what if I mess up the syntax of if? If, 1 is greater than 2, but I forget my colon. Print 3, right? That's bad syntax. I've got 2 syntax errors now. I forgot to put a colon here. It's telling me that. It's got that little underline there. You see how much better that is than waiting to run it to find out? Oh, and it's even giving me a hint down here that this code is unreachable. It flagged that with a yellow mark over here. So not only is it flagging errors, it's even looking at the logic of the code to find out that there are logic errors in it. This code is unreachable. So it's a far better editor. I should probably strongly encourage us to start using it. I should demo it every time we get in here. I still probably won't, but I should. If I can convince you to install this on your home machine and start playing with it and doing your project, your homework with it, you'll be so much happier. So I'm going to fix the syntax errors and prove that it runs, right? I fixed that one. That fixed one of those red lines. I fixed this one by putting the colon there. That fixed that one. This code is unreachable, sure enough, but I'm not going to bother fixing that one. Go ahead and run it again. Cool beans. There's a refactor menu which lets you do things like rename functions, and it'll rename all the function calls so that you don't have to do a search and replace, right? Or go and just manually scroll up and down and change it. Like what if I changed the name of my MULT function? I thought that wasn't clear enough and I wanted to change the name of that function to multiply the whole word. Well, I could do that, but I'd have to change it everywhere it was used. All right, now that you've seen this, I'm going to close it. Pycharm, it's cool.
Also shows you all your indents, whether you're over-indented or under-indented.
Oh, yeah, that's cool. So So what was I saying about refactoring? Well, refactoring, one of the things, refactoring just means changing your code to make it better. And if I call this function something dumb, or if I've changed its purpose, like it's no longer a multiply function, it's an exponent function, don't make this change. But I would need to do that, and then I would need to change it everywhere it's called, right? And sure, you could do that with search and replace, but it's awfully nice if you have a refactor menu and you can highlight something and just tell it to, rename it. And that's not all that refactor does. Be cool, be awesome. Try it out. So expressions, logical operators, and compound Boolean expressions. Now this kind of blows my mind because I don't see star as being any form of Boolean expression at all. Somebody'd have to convince me why taking something to the power of something else is a logical expression. I can't do if A to the power of B and just leave it at that. Automatic negation. Well, what does that mean? Well, if I type in -9, the way the computer really figures it out is that that's the digit. It gives it the value 9, and then it flips it. Oh, by the way, that really means negative. So although we think of minus sign as being part of the digits, it's really an operator. Then we have our math, our regular arithmetic, multiplication, division, addition, and subtraction. Notice that it counts modulus as being part of that category of operators. But they didn't add floor division, which they should have. What does floor division do? It divides and rounds down. Now we're getting into the Boolean stuff. Equal is how you check to see if something is equal to the other. You got to use the double equals if you're doing an if statement or a while. Not equal. I showed you using the word not, but honestly, I almost never actually use it in my code. I would just say not equal, like that. Less than, greater than, less than or equal to, greater than or equal to. Logical negation, not. Logical conjunction, and. Logical disjunction, or, I'm really never going to use the terms conjunction and disjunction again. And assignment, the equal sign. Now this is actually a table of operator precedence. What gets done first? Like, PIMDAS, please excuse my dear Aunt Sally, exponents get done before addition and subtraction, right? Multiplication gets done before addition and subtraction. All of this stuff had better be done before the equal sign copies it into a variable. Ands have higher priority than or. Well, why is that? Remember when I said and was the same as logical multiplication and or was the same thing as logical addition? Well, what has higher precedence? Multiplication. That could be important if you were writing a long if statement with several different ands and ors. By the time you're writing an expression with several different ands and ors, you might think about breaking it up into several different steps because it gets harder to see. I really don't even want to talk about this, but I'm gonna. Short circuit evaluation. Is short circuiting bad? No, not at all. In this case, short circuiting is actually good. And if you were trying to write the most efficient code possible, you would not be using Python. Python's not a fast language. You'd be using C++ or something like that that compiles down to an executable. But what does short circuit evaluation mean? It means that logically it will skip part of the evaluation if it is okay to do so. Why would you skip it? Because every little thing that the computer does slows it down a little bit, right? If this said if A is equal to 1 and B is equal to 1, right, like that, that comparison actually has to execute a few statements on the chip. It may have to load something in from memory, and it may have to shuffle data in order to do this second part. If this part is false, since AND requires both of those to be true, if the first part is false, it skips the evaluation of the second part to speed it up. 99.99999% of the time you don't care. But what if these were functions? If the value returned by the A function was 1 and the value returned by the B function is 1, if you write it like this, if you did not store the results of A and B into another variable before writing your if expression, and if A and B both had to be called, no matter what, for the code to work. Now we've introduced a logic error. Why? Because this executes, it checks it, and if this is false, it would not execute this. So in the rare circumstance, and you should try to avoid this strongly, where expressions have to be called both in order and it's mandatory that both be called, then you better rewrite it. You better write it some way else. How about or statements? If A is equal to B, if A is equal to 1 or B is equal to 1, if this is true, it doesn't need to do the second part, right? Like back to my joke about if you have food, you eat it, whether you're hungry or not, right? So if I have food, I'm not going to even check to see if I'm hungry. I'm just going to eat it. So I don't have to check my hunger status, right, before I decide to gobble down the food. So that's short-circuiting, skipping part of the logical expression based on the first factor, on the first operand. This is considered an operand, even though it's an entire expression and it's a fairly complicated one involving a function call. It's still part of the data that the AND operator needs in order to do it. And a binary operator is something that requires two pieces of data. And an OR are certainly binary operators. Almost all of these operators are binary operators. There's only two of these that are not. And that's a minus sign when you're making a number negative, right? You don't put, if you're doing something minus something, that's actually arithmetic. And the not keyword, right? Because you only have to have something after it. You don't put something before it. I don't remember if there's a test question, a quiz question over short circuit evaluation or not. Just in case there is, I'm going to add it as a comment. And then I better walk about and make sure everybody's doing okay with their syntax errors. So short circuit evaluation for logical, for Boolean expressions, skips the second half of and or depending on the first half. For and, it skips it if the first expression is false, because if the first expression is false, there's no way for the thing to become true. And will skip the second if the first is false. And by the way, in this particular language, if you're going to write false inside of an expression, and you really want it to say false, you capitalize the first letter of it. Vast majority of languages, you use all lowercase for that value. Or we'll skip the second. And if I put quotes around these keywords and or, grammatically it'd make it a lot easier to read. Or we'll skip the second if the first is true. Right? Since it's either or, if the first one's true, you don't care whether the second one's true. If I can stay home if I'm sick or tired, once I determine if I'm sick, I don't even care if I'm tired. I get to stay home.
Oops.
Not going to type up any more notes than that.
Not going to type anymore.
Well, I mean, notes about something else. So testing your selection statements. When you're writing your code, what a programmer always does is just to test it to make sure it works, right? Meaning you test it once and woohoo, right? It did what I wanted it to do. But you need to test all possible results within reason. Meaning that if there's a if statement in it, and it's going to do something if it's freezing, and if it's going to do something else if it's not freezing, run it once to make sure it does the correct thing if it's freezing. Run it again to make sure that it does the correct thing if it's not freezing. If you have a grade program, test it with data to make sure that it's possible to get an A or a B or a C or a D or an F. I've always been confused as to why you skip E in your grades. test all possible paths through your program, which can be difficult if one of the paths only happens, in terms of a critical error. But still, you got to try to make sure that you've logically proven that it'll work. And the best way to logically prove it, or at least one way to logically prove it, is to actually run it and test all possible paths. If I am correctly recalling, one of the quiz questions is worded like this: to test your program, and one of the answers is test with all possible sets of data. Now that's flat out impossible, or it's flat out impractical anyways, right? Because if you're writing something that asks for two numbers and then multiplies them together, there's a whole lot of combinations you could test, right? If it's multiplying two numbers together and it works for both 2 times 3 and 100 times 1,000, right, and 2,000 times 3,000, and then you test it with negative numbers, yeah. By about the time you've tested it 5 or 6 times, you're pretty sure it's going to work for all numbers, right? So this is not correct, and I've had people argue with me about it. Well, don't you want to test it thoroughly to make sure? Well, it's just flat out impossible, right? Because if a value can have 2 billion different possibilities, you're not going to run your program 2 billion different times to test them all. And I think that the other answer, there may be 3, but the one that is correct is test with a representative set of data, right?
If Cengage counts it wrong, you have to change it.
Yeah, that's what test quiz 3 or something.
Yeah, so you remember that one? You spotted that one already? Yeah. So that is correct. And what is your representative set of data? It's a one that tests all the logical paths through it, right? If there's like 4 if statements in it, maybe you have to test it 4 times to make sure that all of them get triggered correctly.
And make sure you don't have any error.
Yeah, so in other words, test all pathways, all logical pathways. If you remember what a flowchart is, if something is true, then it'll branch off one way, also it'll branch off another. You got to make sure that all of the possible paths
You got to do a
work.
little bit more testing.
Yep.
To make sure it's not a float if you don't want a float, or you don't. And you also have to test if it's a string if you want it to be a number.
Yep, we have not covered error handling yet. I do not believe if you type in absolute garbage number, it wants a float, and you type in Fred, it's possible to make it recover from that. So the while loop, it's the exact same thing as if, except once it's done with the code inside the while, it checks it again, and if it's still true, it repeats it again. So while x, do y, like that. Well, if this is an if statement, if x is true, it would do y, and then it would just keep on going on its merry way. But since it's while, if it's true, it executes that, and then it comes back and it checks it again, right? Checks to see if x is still true. And that's looping, right? And looping is really important. Most programs written on the face of the planet involve a lot of looping, right? My PowerPoint right here is looping because if it just ran once, it would just display this page for a microsecond and then close, right? Instead, it's looping, waiting for me to click things. I'm going to throw this word in. I may have used this, I may not have. So say you write an input loop that accepts values until the user enters a sentinel that terminates the input, like this. I don't know why they start talking about sentinels before we even talked about while loops, but like this. We're going to ask for a number, but we're going to tell them that there's a special value that causes the input to quit. So let's ask for that number. Num equals float parentheses input parentheses quote enter a number or minus 9999 to quit. End quote in parentheses in parentheses. So what's that doing? That's our special value that tells it to stop. Enter a test score or -1 to quit, right? Hopefully there's no way you can enter that you can earn a negative score on your assignments. That's a really harsh professor who gives negative scores. I'm not going to do that. So if I was going to write a program that added up scores, I might make it do that. Or it might say enter a number or Q to quit, right? The logic for that might be a little bit different, but we could do it that way. And why not? It'll look better, right? Enter a number or Q to quit, because maybe I really wanted to be able to do 99999. Well, that's going to cause it to crash, because this Q is going to try to get converted into a float. I would have to change the logic of this and do the conversion at a later point. So I'm going to revert this back to -999 for now.
What about -1?
Yeah, I could do it like that. So if number is not equal, so if space, num space, exclamation mark equal to -9999 colon, and I'm going to put a comment here that -9999 is the sentinel value. Just like you have a sentinel at your castle who sets the alarm if something happens. A sentry. Alright, and so if our number is not -999, we're going to do something, whatever it is, like print, parentheses, mult, parentheses, num, comma, num. So you see what it's doing, it's just multiplying that number by itself. Close parentheses 2 times. That may be a little bit too clever by half. Why don't I do this? Result equals mult, parentheses, num, comma, num, in parentheses, and then print the result.
I was about to say, you made a syntax error.
Yeah, so I'm going to run it now, and it's going to be an infinite loop because nothing ever changes the value of num. No, it won't. Why is that? Because did I made it into if? What are we trying to illustrate here?
A while.
While. There we go. All right. So I'm going to enter a number and boom. Why is it doing that? Why is it an infinite loop? Because it never asks for a new value of num. This condition is never updated. This variable is never updated. Since it's never updated, it can't become false. To fix that, I'm just going to copy that input statement, paste it, and tab it over to make it line up with the print. Now it's a good while loop that checks sentry. Right? Keeps printing the squares. Square of 0, 0, square of -1, 1. I'm finally tired of playing around. I type in -999. Now I have a slight beef with the way that this is structured. And the book actually shows how to avoid doing it in the way that triggers my slight beef, which is I have duplicate code here. I'm doing the float input in 2 different places. You just saw me copy and paste. Pretty much anytime you're copying and pasting, you ought to think to yourself, is there a different way to do it? I'll show you the way that you would get around it. You use what's just known as a while true loop. And then you have a break statement in there if the condition ever becomes false. So the stuff inside the while becomes a little more complex, but at least you avoid the fact that you're getting your input twice. Right there and then right there. Getting close to our end here. I'm going to go check something for over. So this is actually a pretty good example of that, but I'm going to do it again. So num equals float, parentheses, input, parentheses, quote, enter a number or 0 to quit, end quote, in parentheses, And this is going to be a little bit more difficult to structure logically, so if you get stuck on this, absolutely text me for help. And so what is this going to do? It's going to calculate interest, or it's going to at least calculate something. And then I need my while statement, while num not equal to 0, colon. We need a second number to multiply. num2 equals float parentheses input parentheses quote. Enter a second number. I'm not going to even let them type in 0 to quit by now. If they don't type in 0 the first time, they're committed. Enter a second number, quote, close parentheses, and then we can call our function, or we can do some calculation based on it. Result is equal to num star star num2, right? We're taking num to the power of num2. Would have been nice if we told them that. Then we need to tell them what the result is. Print parentheses, in the syntax, placeholders, %f for floating point, to the power of %f is %f.
Wait a minute. Is star star
Exponent. Yep, that means to the power of.
then why is it there if it's supposed to be multiplied?
Well, I'm actually taking to the power of. So you're right. Up here I did multiplication, but I'm switching gears on us. Okay, so, and then we need to fill in the placeholders. So num, comma, num, whoopsie, I forgot syntax. After the end quote, do the %sign, and then open parentheses, close. And inside the open parentheses, inside that pair, we're going to print out num, comma, num2, comma, result. And so what's that doing? It's just filling in the placeholders, right? Fill in that placeholder, fill in that placeholder, fill in that placeholder. And last but not least, I need the ability to check again. So I'm going to, just like we did before, I'm going to copy that print statement and paste it and make sure it's indented perfectly to be under print. Now I'm almost running over time, so there we go. I'm going to test it and make sure it works. I will leave this on the screen for you if you have time, or I'll print it out for you. Enter a number, -9999. Okay. Now it's doing the multiplication, although we can't really tell. The exponent, excuse me. So 2 to the power of 3.5 is in fact 11.3. I couldn't have told you that, but now I know. Right, quit. So you're going to take this kind of logic, and you're going to ask, in fact, I'll put that as a comment here, what the homework is. Rewrite your interest program so that it loops until the user enters 0 as the starting amount. Right, because if they start off at 0 money, they're going to end up with 0 money. And you're going to do so based on this logic where you ask for the amount of money, and then if that money is 0, you're not going to do it. So while money is not equal to 0, while A is not equal to 0. All right, let's make a Dropbox for this, and then I'll bring it back up.